Hello everyone, in this video we will discuss Chapter 2, Crystal Structure. The main discussion for this video is about crystal orientation. Before we go into crystal orientation, let us discuss what is crystal structure.
Crystal structure is the orderly arrangement of atoms, ions and molecules in crystalline material. The ordered structures occur from internal arrangement of repeating unit cells along the principal directions of 3D space in matter. The crystal structure will affect the properties of materials.
Crystal orientation can be divided into crystallography point, direction and planes. What is crystallography direction? Crystallographic direction is defined as a line between 2 points or a vector.
How to determine the crystallographic direction? First, choose a point as the origin. Next, draw an arrow from origin to end point. Observe positive or negative in x, y, z direction and count the lattice constant on the directions. Multiply by a common number to get an integer. Lastly, rewrite in the square bracket form and label it in the sketch. Example, determine the direction of the cubic unit cell. First method is using a table. The projection from origin move to negative direction of x-axis, follow by positive direction of y-axis and move upwards to z direction. After that, multiply all the x, y, z direction by 2 to get negative 2, 1, 2. Last, square bracket the answer. Second method is to find the coordinate of the arrow head and tail first. Next, find the difference of head and tail and get negative 1, 1 over 2, 1. Last, multiply the answer by 2 with brackets.
What is crystallography plane? The crystallography plane is joining the direction in 3-dimension and specified by 3 Miller indices as HKL. The integer indices are enclosed within parentheses without commas. What is Miller indices? Miller indices are mathematical representations of the crystallographic planes in 3 dimensions.
How to determine the crystallographic planes? First, set a point as the origin, then construct 3 vector directions. Find the intercepts of the planes along the coordinate axis. After that, take the reciprocal of these intercepts, multiply or divide by common number to get integer. Lastly, remember to enclose the point in parentheses HKL. Let's determine the Miller indices of plane in example 1. As the plane has the intercept on the x-axis is at x equals to 1, y-axis is 1 and z-axis is considered as 3/4. Then we need to change the fraction with its reciprocal to get integer. As a result, the Miller indices for the plane is 6, 3, 4.